If you were forbidden from drawing or pointing, could you describe the exact curvature of a perfect circle to someone using nothing but a list of raw numbers? You would find it impossible. This is Styblox. We are using Wikipedia's foundational documentation on analytic geometry to explore the moment humanity finally merged the physical world of shapes with the abstract world of math. In classical antiquity, mathematicians like Euclid used a compass and straightedge to create flawless geometry. They could construct a perfect shape, but they lacked the language to describe that shape's dimensions with absolute numerical precision. At the same time, the world of early algebra was evolving in total isolation. It was a realm of variables and equations that held immense calculating power, yet it possessed no physical form. It was math you could calculate but never see. For thousands of years, these two disciplines remained separate. Humanity was attempting to decode the universe using two halves of a language that couldn't speak to one another. Ancient Greek thinkers like Apollonius of Perga sensed a connection between geometric properties and numerical ratios. They were close to the answer, but the final bridge remained out of reach. By the 11th century, the Persian polymath Omar Khayyam moved the needle further. He began using intersecting physical shapes to solve complex algebraic equations, bringing the two worlds into the same room. The final breakthrough arrived in the 17th century with René Descartes. He introduced the Cartesian coordinate system. Descartes realized that every point in space could be assigned a numerical address. By doing this, he created a translation engine that turned every physical curve into an algebraic equation. Think of the Cartesian plane like a city grid. Every intersection has a specific address, an x and a y coordinate. If you know those two numbers, you can find any exact location on the map. Plotting y equals x creates a perfect diagonal path. The algebra becomes a shape. But what happens when two lines collide? We use algebraic substitution to solve for one another, pinpointing the exact coordinates with zero margin for error. Physical drawings are often limited by the thickness of a pencil lead or the steadiness of a hand. By moving geometry into the realm of numbers, we can calculate physical reality with infinite precision. But the world isn't flat. To map our actual reality, we have to expand the language by adding a third coordinate, the z-axis. With that single addition, the flat page gains depth. It becomes a volumetric environment where we can track objects moving through three-dimensional space. In this 3D environment, simple quadratic-quadratic equations bloom into massive spheres and complex surfaces. The Cartesian map allows us to move beyond the paper, giving us the ability to map the physical depth of the entire cosmos. This changed geometry from an observational tool to an engineering tool. Mathematicians no longer studied shapes a posteriori, looking at them after they were made. They could now design them a priori, perfecting the structure in numbers before it ever existed. By adapting the Pythagorean theorem to this grid, we can calculate the distance between any 2 points in the universe just by looking at their numeric coordinates. Eventually, mathematicians realized that by changing the rules of the grid itself, altering how we measure distance between points, they could map curved, non-Euclidean spaces. This logic allowed us to visualize the actual curvature of space-time under gravity. Analytic geometry removed the physical constraints of the compass and the straightedge, making the invisible architecture of the universe calculable. This bridge between shapes and numbers is the bedrock of modern life. Without it, the development of calculus, the physics of planetary orbits, and the creation of computer graphics would have been impossible. This system governs everything from the trajectory of a spacecraft to the specific arrangement of pixels rendering on your screen right now. To keep exploring the logic hidden within the universe, subscribe to Styblox. In our next video, we're diving into the strange world of entropy. Because every structure you see in the modern world is ultimately built from this hidden language of coordinates.